Welcome back to our notes. Today we're going to be talking about percent increase decrease, which is topic 3-5. We're going to be continuing to talk about percents, obviously. It's going to be a little bit different, though, than using the y equals mx or part equals percent times whole. If we just go ahead and read what's inside the box here, it says that you can use a percent to describe how much something has increased or decreased. A percent of change describes how much a quantity has changed, expressed as a percent of the original quantity. So people will say, my company grew 45%. Well, they have to figure out what was the original quantity and say from the original quantity, they went up 45%. So what is being shown here in the box is two scenarios, because percent change can either be an increase or decrease. The first one, percent increase, they're showing us that the original height of the tulip was 10 centimeters, and then it had an increase to 15 centimeters. So it grew 5 centimeters. So what we're going to be using is this percent of change equals the amount of change divided by the original quantity. So this 5 right here came from the 15 minus 10. And so the original quantity would be the original height of 10. 5/10 reduces down to 1/2. 1/2 becomes 5/10 as a decimal. 5/10 as a decimal becomes 50%. Because to change a number from a percent to a decimal, you multiply it by 100. So they're saying that the height of the flower increased by 50%. What I like about this topic is how it really relates fractions, percents, and decimals to each other. How really they're saying all the same thing. Then the percent decrease is saying that if the original height was now 20 and our flower is now drooping, it's lost 5 centimeters because it's now gone to 15. We have 5/20ths, which would become 1/4, which is 25/100ths, which is 25%. Jumping into example number 1, they want us to identify the percent increase in each situation. And what we need to do is first look at what they're giving us, the month 1 record and the month 2 record. The scenarios are not going horizontally, they're going vertically. So this is your record for your push-ups, this is your record for your crunches. So month 1 record, that would be our original. The month 2 record would now be the new. This is what I was originally able to do, and now that I worked out, this is what my new record is going to be. So for the push-ups, the amount of change, again, is just going to be the difference between our original and our new. So we have 30 minus 15, which I know you can do in your head, but I'm just trying to show you where it's coming from. 30 minus 15 will give me 15. So if we go back to our notes, it's saying that the percent of change, and in this case, it's an increase. The percent of change comes from the amount of change, which was 15. So I'm going to just put this in parentheses so you guys know where I'm getting this from. Divided by the original amount, and our original amount was month 1's record of 15, so that is our original, which I'll put ORIG. When you do 15 divided by 15, that's going to give us a whole number of 1, but again, in order to change a decimal or a number to a percent, I have to multiply by 100, so I actually get 100% increase. It means I was able to do everything in the first month plus what I did in the first month again, so that's 100%. So for the second scenario again, my amount of change is going to be 114 minus the 100 crunches to give me 14 crunches. So I've increased by 14 crunches. Again, it's going to be the percent of change comes from my amount of change, which is 14, divided by the original amount, which was 100. And this one's kind of done for us because as soon as we have a 100 in the denominator, we know that we're talking about a percent. So we just know our answer will be 14%. Or if you didn't recognize that, you would have gotten 14 hundredths. or the decimal, but then we need to multiply that by 100 to now get 14%. Okay? I'm going to let you guys go ahead and give number 2 a chance. So go ahead, pause the video. When it comes to percents, I like to write more than less because I like to keep track of what the numbers represent. So I'm just showing that the change was the 89 minus 51 to give me 38. The percent of change, again, comes from the amount of change divided by the original amount. So I will get 75 hundredths, which gives me 75%. Question number 3 goes on to say, what does it mean for a quantity to increase by 100%? Well, we've already had an example like this. If we go back to number 1, the original record was 15. For month 2, it went up to 30 push-ups, and that was a 100% increase. Well, how do you go from 15 to 30? You double. So what does it mean for a quantity to increase by 100%? It would mean that it doubles. And just like we can add a number without a percent sign, you can add numbers with percents. So if you think about it, that 100% represents your original amount, then you're going to increase that by 100%. We're going to get 200%. And if I was to change 200% to a whole number, I would get 2. So it makes sense to say that it doubles. Number 4, we'll do that one together, and that'll have you try number 5. Number 4 says that the force of gravity on the moon is different from the force of gravity on Earth. This means that an object has a different weight on the moon than it does on Earth. By what percent does an astronaut's weight decrease in the number on the moon? So the difference here is that instead of talking about an increase, we're talking about a decrease question. So the on Earth is your original, and on the moon is going to be our new. They're not very specific about that. So again, you have to figure out our amount of change, and our amount of change would be 154, and I'm going to put that 0 there, minus the 25 and 5/10. That will get me 128 and 5/10. And so then again, the percent of change comes from taking 128 and 5/10, dividing by the original of 154, so it's always change divided by the original. It will give me approximately 8,344 10,000ths, which when I change it to a decimal versus a percent will give me 83 and 4400ths%. And they weren't very specific here about where I was supposed to round, so I just stopped at the hundredths. Go on, give number 5 a chance. Okay, so for number 5, this is a good little social studies lesson as well, that the number of representatives in the House of Representatives is dependent upon the population. So since there is a census every 10 years, the number of representatives for a state can change depending on the population of every state. I don't know if this is a true fact or not, but just to show you that if in 2000 there was 15 representatives in Michigan, in 2010 now there's only 14 representatives, obviously that is a decrease. So the approximate, we're asking you right here, approximate decrease would be 6 7/10%. If you happen to say 7% because you're rounding to the nearest whole percent, I don't think that there would be anything wrong with that because, again, they didn't specify. So questions 6, 7, and 8 are asking you to estimate the percent of change in each of those. Some of those are an increase and some of those are a decrease. So go ahead and give those 3 a shot, and when you come back, they will be all set. Okay, so example 6 was an increase, example 7 was a decrease, example 8 was also a decrease. I'd like you to just focus your attention on example number 8. Instead of showing my amount of change separately, I just put it automatically in the numerator here of my fraction. If that is confusing to you, you can certainly figure out the amount of change separately and then divide out. But again, you want to think about, we're trying to find the part of the original, so it's the part divided by the original is what ends up giving us our percent. Thanks for watching. We'll see you guys tomorrow.